Assalamualaikum guys, sorry I'm late.
Never mind, Izzati. We just arrived part 2.
That's right, Izzati. So, let's study together. Nisa, why do you look so gloomy? Is there any problem?
Actually, I don't understand about thermophysics. Can you guys explain to me, please?
Oh, I think I can help you. Let me explain about my understanding. So, don't worry, okay? Okay, as we all know that thermal physics is the combined study of thermodynamics, about the statistical mechanics, and also about the kinetic theory of gases, right? So, from this, we all know that there are many things that we can discover under this topic. Okay, I will take part on specific heat capacity and also specific heat, okay? As I know that specific heat capacity is the amount of heat required to change the temperature of 1 gram of substance by 1 degree Celsius. For example, I have 2 buckets, the small bucket and also the large bucket. When I heat up both of them, the small bucket will reach the boiling point first. This is why, because the large bucket need more heat to make it reach the boiling point. This indicates that the large bucket is having the larger specific heat capacity more than the small bucket. Okay, for in the class, we can use the formula C equal to Q over M delta T, which is C represent the specific heat capacity, Q represent the heat required, M represent the mass of the substance, and delta T represents the temperature change. And also we need to know that in the isolated system, which is the container that is tight container, the heat gain is equal to the heat loss.
Wow, you are right, Izzati, and such a good explanation from you. So, Nisa, I will continue to explain about latent heat to you, okay? So, as for me, what I understand about latent heat is latent heat describes an energy absorbed or energy released by a substance when it changes its physical state. Okay? Okay, so Nisa, now latent heat is divided by 2. First, latent heat of fusion, and second one is latent heat of vaporization. I will explain to you each of them. So first, you need to know that latent heat of fusion is the quantity of heat required to change a unit mass, which is 1 kg of substance from solid to liquid, from liquid to gas, or the other way around. Okay? Okay. So, the second one is latent heat of vaporization. Latent heat vaporization is when the quantity of heat that required to change a unit mass of 1 kg substance from liquid to gas, or another way around. Okay, that is 2 types of latent heat. Okay, guys. So we can calculate the latent heat by using this formula. Okay, Q equal to ml. So the Q here representing the heat absorbed or released during the changes occur, while M is for the mass of the substance, and L stand for latent heat of the process. Okay, so we also can use this equation to calculate latent heat.
Now I understand about specific heat capacity, and latent heat. Then, how about the heat transfer mechanism?
Alright, chill, Nisa. Here, take a bite of Kit Kat first. Catch. Well, heat transfer mechanism is the heat flow, which is thermal energy from a warmer to a colder object in 3 different ways, namely conduction, convection and radiation. Now, let me explain more about radiation. Well, radiation is a mechanism in which energy is transmitted by means of electromagnetic waves. The first one, which is the rate of heat transfer by emitted radiation, this type of radiation can be determined by using the Stefan-Boltzmann law of radiation, which is Q over T equal to element multiply sigma multiply A multiply T power of 4. Element of the object is a measure of how well it radiates, called the emissivity, is a number between 0 and 1, while sigma is the Stefan-Boltzmann constant, which is have a value of 5.67 multiply 10 power of negative 8, while A is the surface area of the object, and lastly, T is its absolute temperature in Kelvin. Next, number 2, the rate of heat transfer by radiation from the sun. This radiation cannot be calculated using previous equation, but we will be using this equation. Q over T equal 1000 multiply element multiply A cos theta, which is 1000 here to show solar constant, while theta is the angle between the sun's rays and a line perpendicular to the area. Alright guys, to expanding our knowledge about radiation, I will give you guys one example of the application of radiation that we're familiar with, namely thermography. In medical, EMI scan is used to scan the body, measuring the intensity of infrared radiation from many points and forming a picture that resembles an X-ray. Look at this figure. As you can see, figure A shows thermograms of healthy person's arms and hands, while figure B shows the person's arms and hands after smoking a cigarette. This showing a temperature decrease due to impaired blood circulation associated with smoking. So, that's all about radiation. Now, Pia will continue with the convection. Okay?
So now I will continue to explain about convection. So Nisa, you want to know, convection is the transfer of heat by circulating it through the air or liquids. So unlike conduction, which conduction must be direct or indirect contact between the two objects for heat transfer to take place, right? But convection, it relies on the circulating motion of the molecules in order to transfer heat. So this is the two different things between conduction and convection. Okay Nisa, to make you more clear about convection, I will give you a daily life example, okay? So let's say you are heating a pot of water on a stove, alright, which is a metal pot, okay? So when you put the pot onto the stove, turn on, after a few minutes, the pot will turn hotter, right? When you touch the pot, it is because of the conduction, because the pot is directly touch the flame, right? Okay, so difference for the water inside the pot. For the water inside the pot, they use convection reaction, okay? They are not conduction, but it's convection. How? So as the bottom part of the water touching the bottom part of the pot, right? So the bottom part of the pot is increasing in temperature because it's direct to the flame, right? So when the bottom part of the water touch the hot iron pot, right? So the heat will transfer to the water, and the water that has been heated, it move to the top, okay? So the cold water on the top is pushed downward towards the hot bottom of pot due to the convection currents, okay? And the process continue until all the water is being heated. Do you understand? Yes. Okay.
If so, conduction is the process where heat is transferred through a material and the bulk movement of the material does not play a role in this conduction process. Right? In this process, atoms or molecules that are in a hot pipe will vibrate or move with more energy than atoms or molecules that in a cool pipe. So the heat flow, which is delta Q over T, given by like this, right? Where K is proportional constant that called thermal conductivity, while A is the cross-sectional area of the object, and L is lag between the hot and the cool pipe. So, if we want to find thermal conductivity, which is K, we can rearrange the equation so it will become like this. And the unit for K is joule over meter second Celsius or watt over meter Kelvin. Oh, I have heard that if the thermal conductivity, which is K of the molecule, is higher, the material is called conductor, while K is lower, the material is called insulator. Now I understand about this thermophysics. Thank you guys for teaching me.
You're welcome, Isa. A good friend, we help each other, right?
Hey, teaching Nisa about thermophysics make me feel very hungry. Can we go eat after this, please?
I also feel starving. Let's have a bunch at Aunt's Ruby restaurants across the park.
Ooh, let's go!